All right, so what'd you get for your minimum? We got, let's see. Aaliyah, where's your minimum at? X equals 1. Because. Tiffany, what's your because? Okay. Beautiful. All right? That's all I want to see. I don't want to see a paragraph. I don't want to see your own explanation because you're way too wordy. That's all you need. That's a perfect reason. All right? Second guy. So we're going to do the same thing. We're going to first answer the question of, given that there's an undefined, label it as a discontinuity, a corner, a cusp, or a vertical tangent. So, what does this mean that it's crossed out? Has to be a discontinuity. Crossing out means discontinuity. It means it's not part of the domain. All right, this undefined, you got to actually look at your signs. They went from plus to minus. Remember, this is F prime. Sorry, I forgot to write it there. If we're going from plus to minus and it's undefined, all right, Isaac, give me one possible point it could be. It could actually be a corner. There's only one other possibility it could be. Ruth, what's the other one? Cusp. Nick, why can't it be a vertical tangent? Stay with the same sign for vertical tangents. Perfect. All right, next question. EVT. Danny, why not? No, because, and I'm going to actually state exactly why, because discontinuity at x equal to -9. So it fits one of the two things. Which one does it have? It's closed, but it doesn't have continuous over. Okay, perfect. So now, this one, draw your function. I want you to count up how many minimums and count up how many maximums. I'm going to ask you with your fingers to tell me how many you have. If you think there's 5, then you're going to put up 5. So count them up. Give you a second for that. All right, fingers in the air. How many minimums do you have? All right, I'm not going to say if you're right or wrong. All right, and fingers in the air. I want you to tell me how many maximums you have. Okay, so for each question, we've had anywhere from 1 to 2 and then 1 to 3. All right, let's take a look. So, just like before, we don't have an arrow. I want you to start at a closed endpoint. So, close, start it, and then what am I doing from there? Going down. I'm skipping over this because it's not part of my domain. Going up, and then flat, and then up. I skip over my undefined because I don't really know what's happening. Okay? Down, flat, up, and closed endpoint. If it's an open endpoint, keep it open. Are you allowed to use open endpoints? Are they part of domains if there's an open endpoint? No. Okay, so if there's an open endpoint, you can't use that point. It better be crossed out. All right, so the first question I asked you was how many minimums? I'm assuming you all found the same one minimum. Is it that one? Is that a minimum? No, why not? It's not in the domain. It can't be one of your special points. So make sure you didn't count that one. I'm assuming the other one would have been here. All right, so there's one minimum. All right, we got that guy, and then we have this, no, wrong place, this one. There's your max. So 1 and 1. Correct? Well, about half of you should say yes, because half of you said maximum was 1. There were some of you that had more of them. Some of you had 3 in the air. You had 3 in the air? Right, you had 3 in the air? What do you think, where are your other 2 magically coming from? Are you making them up? The endpoints? You're telling me that this is a max? Can you explain why you think it's a max? After it goes down. Okay. True. Oh, be careful. The F prime values don't decrease. They are negative. F decreases, but F prime does not. So far, okay, I'm with you. Has he convinced anyone, or are we still telling him he's crazy? We're starting to agree. Not everyone, though. He might be crazy. He might be crazy. Draw a point and go down. Is that our highest point in that area? Yeah. He's not crazy. Well, he could be crazy, but he's actually right. Okay? That is a maximum. And this guy here is also a maximum. Why? Because in that neighborhood, that's the highest point. Okay? Now, because EVT didn't hold, we don't have to say absolutes. Your graph might not be accurate. Okay? This might not be the highest. It might be that it goes up a little bit like this, and then goes down really low and comes back up like this. And if that happens, that wouldn't be the absolute max. So I don't want you to think that this kind of fake graph that you're giving shows the accurate y values. It doesn't. All right, so I'm going to do one of your endpoints for you. Let's do a max at x equal to negative 11. So if I have a maximum there, if it's an endpoint, you got to tell me which one, left or right. Left side or right side? Left. So that's the first part. You have to tell me what kind. And you got to tell me how did you know. So what right told us was it was here, and then the graph went down after. But what told you that it went down after? These little minus signs. So, and f prime is negative after. That's good enough. That's actually just enough information for you to get full credit. All right, you have your maximum at negative root 2. Oh, sorry, x equals. So finish your statements all the way through. You have a minimum at x equal to positive root 2. And then you have, at the very end, another maximum at x equals 3. I'm pretty sure you guys can do your in-between interior points. I'll do one more endpoint for you because I believe that you guys can do the other ones. I'll do the max endpoint one. So your endpoint, which endpoint is it? The right endpoint. And what do we know about f prime that told us to graph it that way? F prime is positive before. Let's see, I guess I should write out the word before. There you go. Those are the reasons I want to see. If you write more than that, you're just wasting time. We don't want to waste time. All right? The other two, I'll leave for you guys if you want to practice a few more. I'll leave that for you. I want to go through algebraically finding max and mins. I'm going to give you a 5-step process. You may choose to memorize the 5-step process. I would highly encourage it because it guarantees you don't miss a step. But it is possible to do the steps in different orders, okay? So you don't have to do it in step 1, 2, 3, 4, 5, but I'm going to give it that way. So you got to think about how we got to the point of having this beautiful, magical sign chart, okay? So let's go back through and talk about the first thing we looked at. That very first question, I asked you to look for what? At the very beginning of the question. Very beginning of the first sign chart that we did together. So that was this one. Well, we did check if it held, but we did a few things before that. We looked for discontinuities first. I was kind of training you in the steps secretly. So the first thing you want to do in your steps, you actually want to check for your domain. And what does that really mean? It really means you're checking for discontinuities. What are the 3 types of domain issues we talk about? Okay. Isaac, give me one. Types. Oh, I should say it differently. How can I tell looking at a function that there might be a discontinuity in the domain? Does that change? Thank you. That is 0 in denominator. All right. Other ones that we have? Danny? Natural log, so x in natural log or log. Now, you want to give me the last one? What's missing? And we'll call it x in even root, just in case we do higher roots than squared. All right, those are our major things we look for. So if none of those happen, you're probably good for your domain. All right, then the next thing we looked at before we got to EVT was this would check off continuity. What's the other thing we got to look for EVT? if it's closed, and I'm going to name it differently, endpoints. I'm looking to see if there's endpoints, and if you want to call that closed, that's fine too. Okay? If your domain shows up that you have parentheses, let's say, you don't have to write this here, you may if you'd like. That's your domain. You magically figured out that that's the domain. Is it closed? No, it's not. What do the parentheses mean? It's open. This is closed. Okay? So these are open, and this is closed. This one closed has endpoints, the other one does not. Okay? Be careful with that. All right, so right here, at this step, now you can check if EVT holds. Why is that important? Because if it holds, Matthew, what are you guaranteed if it holds? Be careful. EVT, extreme value theorem. So if this was a quiz, I would mark you off. What are you missing? Lottie, what's he missing? Absolute. That's important. Absolute's important. You will 100% have a highest and a lowest point. All right, so that's kind of a side step. You want to know that. Why would you want to know that? Because let's say you said it holds, and at the end you tell me, oh, there's no max or mins. You can already see you had to have done something wrong somewhere. Okay? All right, third step. Well, once you did that, we magically had a sign chart, but normally it wouldn't be there. Normally you got to make it. So what's the first part of making a sign chart? Well, first of all, you got to find your F prime, right? Right? You got to find this guy, set it equal to 0, and find this guy and set it equal to undefined. But to do that, Danny's right. You want your F prime completely and utterly simplified. Completely. And we'll do notes on the next page for that real quick. All right, once we do that, we're going to use F prime to make sign chart. And the last step is actually an optional step based on the question. If finding absolutes, let's say you have 5 maximums, 5 of them. How would I know which one's the absolute? And I already know EVT holds, so I'm guaranteed an absolute. How could I magically just figure this out? Do I guess? Do I pick? Lottie? The Y values. Because if I have one maximum here, one maximum here, one maximum here, and one maximum here, how would I know which one's the absolute max? The largest one, the highest one. So, if you're finding absolutes, you make this table. You do an XY table of all the possibles, and then here, I sometimes just say max or min. Because sometimes there's both. So I just do a nice little XY table. So if I want Y values, where do I substitute my X's back into? The original function. Don't get tricked. You don't put it into the derivative, because I'm not looking for derivatives. All right, there's everything. You actually did all of that, except for step 5, because I never gave you any Y values. But I did it in a weird way where you just kind of did a little piece of each. So just reviewing real quick, creating your sign charts, I want to just do some reminders. Remember that F prime, you want it to be completely and utterly simplified. Oh, actually, no, don't write that. I changed it, I remember. I did it generically. I said, if you're making a sign chart, I didn't write F prime. You want the function of whoever you're making a sign chart for. Why do I say that? Because in 2 sections later, you're going to have to do F double prime sign charts. So if I ask you to do a sign chart for F double prime, then I don't care about F prime. I care about F double prime being 0. And I care about F double prime being undefined. What if I ask you to do a sign chart for the Y values? Then I would do the Y values equal to 0, and I would do the Y values equal to undefined. Depends on who. What if I want a sign chart for velocity? Velocity equals 0, velocity equal to undefined. If I want the sign chart for acceleration, acceleration equals 0, acceleration equals undefined. This is general notes. You can now do a sign chart for anything and everything I tell you to do it for. So that's one thing. That's your kind of first step. Second, you use function to find positive or negatives. And then we're going to talk a little bit about some special functions. So a special function. That's a special function, because when you're doing a sign chart, what do you know about this as a factor? E to the anything. If I was doing a sign chart just for e to the x, let's say. So mentally you should be graphing e to the x. You should notice something about its sign. And signs are positive, negative, 0, or undefined. Number one question, can e to anything be undefined? Nope, it cannot. Domain is all real numbers. Can e to the be negative? Meaning, does your graph ever go underneath the x-axis? No. So this is always positive. That's important to know, because what if you have a ridiculously ugly f prime, but it happens to have e to the x as a factor? What do you get to do with that? Ignore it. You don't have to do anything to it, because what will you always get, no matter what number you put into e to the? Positive. Positives don't do anything. What are some other functions that always give you a positive value in the end? Without mumbling. Tiffany? Absolute value. Okay, I'll take that. Oh, I didn't even give that one yesterday. Absolute value. Always positive. That's a good one. I didn't even think of that one. Other ones, right? Even powers. Always positive. One's missing. Even roots. Because you can't take the square root of a negative number. You can only take them of positive numbers. That's also always positive. And then Danny said the one I wanted to talk about. ln. Graph it. Or log. Graph it. Once you graph it, you should be able to tell. Does it have positive, negative, 0, or undefined? So, graph it in the air. Starts down low. Comes up like this. So, does ln have negative values? Yeah, it does. ln looks like this. And this point is 1, 0. So ln can be negative, it can be 0, and it can be positive, and it can be undefined. It has everything. ln has everything. So ln's not one of our special easy things. So let's say I gave you this nice problem, and this was the derivative. This whole thing just multiplied together. Then you're guaranteed the derivative is always positive. You don't even have to do a sign chart for it. All right. So I'm going to go through one example with you, and then if we have time, I'll go through the domain of the last one. We're going to find absolute maximum and minimum values on this function, and we're going to do the step process. It's just to show you all the things you need to do. So the first thing you're supposed to find is your domain. So I have an even power. Can I square any number? That's what this is. Can I square anything? Yes. Can I cube root anything? Meaning, can I take the cube root of negative 8? Is there a number multiplied by itself 3 times that gives you negative 8? Yes. What is that number? Negative 2. Odd roots are okay. Do you remember a second ago? Odd roots are okay? Because even roots are the ones that have the issues. Odd roots are fine. All right, so domain is all real numbers. There's no discontinuity is what that means. And then we already have endpoints of negative 2 to 3. So what does this tell me? EVT holds, which was why I can ask you for the 2 things I asked you for, absolute max and absolute min. Get into good habits. These are good habits to have. Third, which reminds me of a piece of the notes I forgot to give you guys. Let's backtrack one quick second. Before you do this, your f prime, someone mentioned it, had to be simplified. What does simplified mean? What are the 3 things I asked you guys to do for simplified? Travis, your favorite? Factor. What if there's fractions? You need to have 1 common denominator, greatest common denominator. You're only allowed to have 1 fraction total. And what's the last thing that's going to happen in this guy when you take its derivative? Negative exponents. Get rid of them. I'll show you in a second why we do that. So, easy derivative, right? 2/3 x to the negative 1/3. If you see that, you don't necessarily know that there's undefineds in here. It just doesn't pop out. But what happens if you rewrite it? This means that this term x has to go downstairs. So what do we have in the numerator? 2. What's downstairs? 3x to the 1/3 is a little more obvious that you have undefineds. Fractions make everything easy. Make the top equal to 0, make the bottom equal to 0. That's why I want that to happen as one fraction. You can't have 2, you can only have 1. So here's what I do right after this. I always, without even thinking about it, I just write this down right away. I just write it down so I know I'm checking both. If I set my f prime equal to 0, I'd actually only get this, right? Look similar to your homework? This step that I'm making you do now. How do I make it undefined? Denominator equal to 0. Divide by 3. How do I get rid of a 1/3 power? Not multiply. Cube it is what you're trying to say. It's not powers don't multiply. You're cubing the whole thing. All right. And when you do that, you get 0. I'm going to backtrack a little bit. This should make total sense why we have an undefined derivative at x equal to 0. Let's go back to the beginning. What power was there? What does that tell you definitely have? Oh, be careful. Even over odd. You have a cusp. And we already know where it is because you can tell from who has the power, right? And then this is the other thing I do with every single AP problem. If there's endpoints, I circle it and I say the word endpoint. Why do I do that? Because they're probably important. Theorems, maximums, minimums, you always highlight those. Okay, so this makes total sense. And then, step 4, make your sign chart. First of all, label your sign chart. You should be labeling functions. It should say f prime equals 2/3 x to the f prime. I'm doing only from -2 until +3. So I only do those. I don't want to see any other numbers. I don't want to see -2, -1, 0, 1, 2, 3. I only want to see critical. That's my critical point. Put an undefined. Should I cross it out? No, because what did we figure out? Domain was all real numbers, no discontinuity. And then we're going to substitute in -1. Where am I substituting this into if I'm doing f prime sign chart? F prime. So put -1 in here to the 1/3 power, which means cube root of -1. Is it positive or is it negative? It's negative. 1, put it in, cube root of a positive number. Am I saying this and I'm the only one that knows this, or do you guys know this? I'm picking numbers. I'm doing a sign chart. Right? So, draw. I'll do that in bright green. Endpoint. What am I doing after the endpoint? Down. I skip over these because I don't really know what it looks like. And then I go up to an endpoint. So, do we know what we have here? At 0, I have a minimum. I'm just going to call it a minimum for now. And then at -2 and +3, what do we have? Oopsie. Give me 1 second. EVT holds, so what do you know this has to be? This has to be absolute because EVT held. It's the only minimum, got to be the absolute. So how do I know between these two? So step 5, I'm looking for my absolute max, and I'm going to do x, y, -2, +3. Into the original function, I'm even going to write it right here for you so you don't forget what you're going to substitute into. So, you can cube root it first or you can square it first, whatever's easier. I think squaring first is easier. Square that, we get 4, and then you're going to take the cube root of 4. Next one, square it, and then we're going to take the cube root of it. What's bigger? The cube root of 4 or the cube root of 9? Cube root of 9. So here's my reason. X equals 3 is my absolute max because f of 3 was bigger than f of -2. I do that in, you can do it in words. Tell me it in words. I actually can't remember if this is allowed. That's why I'm making you do the extra statement. I actually think that this isn't allowed to be reasoning. You have to do this That's why I'm doing that piece right there. Okay? So tonight's homework is practicing. I think your practice problems are actually maybe even a little bit easier than these. This one wasn't too bad, though. All right? I'm out Wednesday through Friday. You'll have Miss Stedman. I'm still trying to decide between letting you guys go to the lab and watch the videos on your own. Is that more comfortable than watching it as a class? Okay. All right. If there's a lab available, I'll do that for you guys.